Hello students, today we will start exercise or solution of chapter 15. Okay, now in this video we have solved exercise 15.1. Now come to the question number first. Yes, what is the first question? So the first question is complete the statement first probability of an event plus probability of event not E. What will the answer? Answer is 1. You can see that here is the answer. Use cursor. Yes. Now second statement, the probability of an event that cannot happen is. It cannot happen. That means impossible event, and we know the probability of impossible event is 0. Such event is called impossible events. Now third question, the probability of an event that is certain to happen. Certain, that means surely. Therefore the probability of that event is 1, and such type of event is called sure or certain event. Next question, the sum of the probability of all elementary events of an experiment is always 1. Clear? We have already discussed in the chapter. The last question of first, the probability of an event is greater than or equal to 0 and less than equal to 1. That means probability of an event is always greater than or equal to 0 and less than or equal to 1. The next question is, which of the following experiment have equally likely outcomes? First, a driver attempts to start a car. The car starts or does not start. First of all, what do you mean equally likely events? Equally likely outcomes, that outcomes in which the probability or happening of chance equally divided 50-50%. Now first, driver attempts to start. In this action, driver attempts to start a car. The car start or does not start. Maybe we are not justified to assume that each outcome is equally likely. Thus the experiment has no equal. Suppose maybe car is not working. Okay. The second question, a player attempts to shoot a basketball. She or he shoots or miss the shots. A player attempts to shoot a basketball, shoots or misses the shoot. We are not justified to assume that each outcome is as equally to occur as the others. Thus, the experiment has no equally likely outcomes. There is no 50-50 chance for these. Okay. And the third is, a trial is made to answer a true-false questions. The answer is right or wrong. In this case, either the answer is right or wrong. Therefore, this can we say that this situation or this event has equally likely outcome. Okay. True or false question, right or wrong, we know that in advance that the result can be lead into one of the two possible, either true or false, either right or wrong. Therefore, we can reasonably assume that each outcome, right or wrong, is likely to occur as the other. That means here the 50-50 chance for both. Clear? Fourth, a baby is born. It is a boy or a girl. What is the answer? In this the experiment, a baby is born. It is a boy or a baby girl. We know in advance that The outcome can lead in one of the two possible outcomes, either a boy or a girl. We are justified to assume that each outcome, boy or girl, is likely to occur as the other. Thus, the outcomes boy or girl are equally likely. Now, question number 3. What is it states? The statement for this question is, yes, why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning or of a football game? You know, in cricket or football, we toss a coin, decide who will bat first or fielding first. Similarly, in football, who throw the ball first. Uh, the answer is the tossing of a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game. Why? As we know that the tossing of the coin only land in one of two possible ways, either head up or a tail up. Therefore, it can reasonably assumed that each outcome, head or tail, is as likely to occur as the other. Therefore, here 50-50 chance for both either head or tail. The outcomes head or tails are equally likely. So, the result of the tossing a coin is completely unpredictable. That's why tossing a coin is considered to be a fair way of deciding. Now, question number 4. Which of the following cannot be the probability of an event? 2 by 3, minus 1 upon 5, 15%, D, 0.7. Now, here 2 by 7, 2 by 3. What do you mean 2 by 3? 2 by 3 is less than 1. This is less than 0. This is 15. Sorry. 15 upon 100. That means 0.15, which is also less than 1, and 0.5 is also. And we know that probability of any event is always greater than equal to 0 or less than equal to 1. Here the option B is minus 1.5 cannot be the probability of an event. Why? Because probability of any event is always greater than equal to 0 and less than equal to 1. Clear? Now, question number 5. If P of E is equal to 0.05, then what is the probability of not E? Here, what we have? We have to find the probability of not E. That means the complement of E. And we know that probability of E and probability of not E is equal to 1. Sum of probability of E and complement of E is equal to always 1. Therefore, P of not can be found by 1 minus P of E. That means 1 minus probability of happening of E, which is 1 minus 0.05. Therefore, our required answer is 0.95. And you also know P of not E is denoted by P of E bar. Clear? Now, question number 6. A bag contains lemon flavored candles only. Malini takes out one candy without looking into the bag, what is the probability that she takes out an orange flavor candy, a lemon flavor candy? Now for first, what we have to find? An orange flavor candy. Probability of getting out a orange flavor candy. Okay. Now, for event related to experiment of taking out an orange flavor candy from a bag containing only lemon flavor. Okay. What is given? A bag contains lemon flavored candles only. Okay. Sorry, candy only. And Malini wants orange flavor. Therefore, in this case, no outcome gives an orange flavor candy. Therefore, it is impossible event. So, its probability is 0. Clear? And we know that the probability of impossible event is 0. And second, a lemon flavor candy event, taking a lemon flavor candy out of a bag. Only lemon flavored candies are there. Therefore, all the lemon candies are the outcome, possible outcome. Therefore, it is a certain event. Hence, the probability of this event will be 1. Now, question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. Then what is the probability that the student have the same birthday? I repeat the question. The probability of 2 students not having the same birthday is 0.992 out of 3 students, and we have to find the what is the probability that 2 students have the same birthday. Again, we have to find the probability of not happening of E. So let E be the event of having the same birthday. That means P of E is equal to 0.992. It is already given, and we know that P of E plus P of E bar, which is P of not E, is equal to 1. Hence, P of E bar is equal to 1 minus P of E. Therefore, 1 minus 0.992. After simple subtraction, we get probability of not E 0.008. Okay. Therefore, the probability of 2 students have same birthday is 0.008. Now, question number 8. A bag contains 3 red balls and 5 black balls. Okay. Therefore, total balls are 3 plus 5, 8. Clear? A ball is drawn at random from the bag. What is the probability that the ball drawn is? First, a red ball. Second, not red. Okay. Here, first, how many possible outcomes are there? 8 balls. Okay. First, we have to find the probability of getting a red ball. Out of 8 balls, there are 3 red balls. Total element events are 8. We can get any ball from it. Bag contains 3 red balls. Therefore, 1 red ball can be drawn in 3 ways. Favorable number of element events for red ball 3. The P of getting a red ball is equal to number of favorable outcome to the event upon total outcome, which is 8. Clear? Now, since the bag contains 5 black balls along with 3 red balls, therefore, 1 black, not red, ball can be drawn in 5 ways. Favorable outcome 5. So, getting a black ball 5 upon 8. Clear? You know that the formula for probability of any event is equal to total number favorable to that total favorable outcome to that event upon total number of outcome. Now question number 9. Box contains 5 red marbles, 8 white marbles and 4 green marbles. 1 marble is taken out the box at random. What is the probability that the marble taken out will be a red? First of all, we have to find how many marbles are there. 5 plus 8 plus 4. That means there are 17 marbles. Out of, we have to find probability of getting a red or white or not green. The first total marbles 17. Therefore, total number of elementary events 17. Any marble can draw. And first, for getting the probability of red ball, there are 5 red marbles in box. Therefore, favorable number of elementary events for red marble is 5. By the formula, favorable outcome to the event upon total outcome 5 upon 17. Clear? Now, second, white. There are 8 white marbles in the box. Again, the P of getting a white marble 8 upon 17. Now, not green. There are 5 plus 8 13 marbles in the box which are not green. 5 red, 8 white. Therefore, favorable number of elementary events for not green is 13. So P not getting a green marble is 13 upon 17. Clear? Here we simply use number of favorable outcome to the event upon total number of outcome. Now question number 10. A piggy bank contains 150 paisa coins, 50 rupees 1 coins, 20 rupees 2 coins and 10 rupees 5 coins. If it is equally likely that of the coins will fall out when the bank is turned upside down, what is the probability that the coin first will be a 50 paisa coin, second will not be a rupees 5 coin? So first of all, we have to find the total number of outcome of the event. What is the event? Event number of coins. The total number of coins in a piggy bank, in this piggy bank is 100 coins, 50 paisa plus 50 coins, 1 paisa, 20 coins of 2 paisa, 2 coins and 10 of 5. Therefore, total coins are 180. The total number of elementary events 180. Now first 5 paisa coin. So how many 5 paisa coin? I had 100. Total 180. So 100 upon 180. After solving we get 5 upon 9. Similarly, we can find the probability to be not a 5 rupees coin. So there are 10 5 rupees coin. So we can subtract or can we add remaining coins 100 plus 50 plus 2 equal 20 equal to 170 coins rather than rupees 5 coin. So favorable outcome 170, formula favorable outcome 170 upon total outcome 180, 17 upon 80. Clear? Simply in each question we have to find first what is the event and how many total outcomes, and then according to event we have to find the favorable outcomes. Now question number 11. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fishes and 8 female fishes. Okay, diagram is in your book. What is the probability that fish taken out is a male fish? Again, we have to find what is the event. We take a fish. We taken a fish out. Okay. So again, we have to find the total number of fishes. The total number of fishes in the tank is 5 plus 8, 13. 5 plus 8, 13. 5 male or 8 female. Okay, there are 5 male fishes. What is the event? Getting a male fish. That is the event. So we have to find the favorable outcome for male fish, which is 5. The 5 upon 13 is the solution. Now question number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. You can see the diagram. And these are equally likely outcomes. Okay. What is the probability that it will point at first 8, second an odd number, third a number greater than 2. Fourth, a number less than 9. Okay. What is the question says? The question says we have an spinning, okay, an arrow which comes to rest at pointing where numbers are 1 to 8. Okay. Then we have to find what is the probability that a point will stop at 8 first. Out of 8 numbers, arrow you can see in the diagram. There is a spin numbering 1, 2, 3, 4, 5, 6, 7, 8. First, how many 8s are there? Only 1. Therefore, the point will comes at 8 only once. Therefore, favorable event outcome for 8 1. Total outcome possible outcome each the 1 upon 8. Now question number 2, an odd number. Again, how many odd numbers are there? 1, 3, 5, 7. The 4 odd numbers are there on the spin. Therefore, the probability of arrow points at odd number is 4 upon 8, which is 1 upon 2. A number greater than 2, that means 3, 4, 5, 6, 7, 8, all are greater than 2. The total favorable greater numbers are 6. The probability of arrow points at a number greater than 2 is 6 upon 8, 3 upon 4. Last of this question, a number less than 9. Less than 9, all numbers are less than 9. Therefore, favorable outcome will be 8. The probability of arrow points at a number less than 9, 8 upon 8, which is 1. Clear? Now question number 13. A dice is thrown once. Find the probability of getting a prime number. Second, a number lying between 2 and 6. Third, an odd number. First, you know that total number of favorable outcomes of throwing a dice, possible outcomes 6. 1 to 6, 1, 2, 3, 4, 5, 6. First, a prime number. You know what is prime number? And prime number which is divisible by itself or 1. That means it has only one factor, which itself. On dice, we know that 2, 3 and 5 are the prime numbers. Therefore, favorable outcome for this event is 3 for getting a prime number. Therefore, probability of getting a prime number is 3 upon 6. 3 out of 6, therefore 1 upon 2. Second, a number lying between 2 and 6. On a die, the number lying between 2 and 6 are 3, 4, 5. Therefore, favorable outcome 3. And B, getting a number lying between 2 and 6 is 3 upon 6, which is 1 upon 2. Third, an odd number. We know that on a dice, odd numbers are 1, 3 and 5. Therefore, probability favorable outcomes for our event 3, hence probability of getting an odd number is 3 upon 6, 1 upon 2. Clear? Here we have done today question number 1 to 13 of exercise 15.1. In second part, we will solve remaining question of exercise 15.1. Thank you.